Good evening, all of you. Today I am going to introduce a new concept, that is electromagnetic spectrum, types of the radiations according to the wavelength, then the statement of the Lambert's law, statement of the Beer's law, their mathematical expression, then the combined Lambert's Beer's law. This point today we will see. Now let's start with the electromagnetic spectrum. See, this is the electromagnetic spectrum. Electromagnetic spectrum. The electromagnetic spectrum are classified on the basis of what? Their wavelength into the different categories, right? The classification shows that this is your cosmic rays. Cosmic rays having the shortest wavelength, and the radio wave it having longest wavelength. Okay, and as we move from left hand side to right hand side, right, the wavelength goes on increasing from left hand side to right hand side. Lambda value goes on increasing, and energy and frequency goes on what? Decreasing. We also see the human eyes can be recognize the color of the radiation in the region of what? 400 nanometer to 800 nanometer region, right? Which is very small region compared to the whole spectrum of electromagnetic radiation. Therefore, the region is called as what? The visible region. Okay. Now, the next important point is the Lambert's law. The statement of Lambert's law is when a beam of monochromatic light is allowed to passing through a transparent medium, right, it decrease intensity of incident radiation is directly proportional to the path length at constant concentration, right? The mathematical expression is minus di upon I0, which is directly proportional to what? Dx, right? I will again repeat. When a beam of monochromatic light is allowed to passing through a transparent solution, it decreases intensity of incident radiation is directly proportional to what? Path length at constant concentration, and mathematically it is expressed minus di upon I0 directly proportional to what? Dx. Okay. In other words, absorbance is what? A. Absorbance A is directly proportional to what? Path length at constant concentration. So A is directly proportional to what? Path length at constant concentration. So this is the mathematical statement of what? Your Lambert's law. Then second one is Beer's law. The statement of the Beer's law is when a beam of monochromatic light is passed through a transparent solution, decreases in intensity of incident radiation is directly proportional to concentration at constant path length, right? So mathematically it is expressed as minus di upon I0 is directly proportional to what? Dc. So this C stand for what? Concentration, right? You remember this one, Beer's law is related to what? Concentration, and Lambert's law is related to what? Path length. I will again repeat the statement. When a beam of monochromatic light is passed through a transparent solution, decrease in intensity of incident radiation is directly proportional to what? Concentration at constant path length, and mathematically it is denoted by what? Minus di upon I0 is directly proportional to what? Dc. In other words, in short, this absorbance is directly proportional to what? Concentration. Okay. So this is the mathematical statement of what? Your Beer-Lamberts Law. Then next one is combined Beers and Lambert's law. Actually, it is the combination of two law. Which one? Beer's law and Lambert's law. The statement is what? It is stated as absorbance A, means this, is directly proportional to what? Both path length and concentration. So absorbance A is directly proportional to path length as well as the concentration, where this small a, this is the small a, it is known as what? Proportionality constant, or which is also called as absorption coefficient. Okay, or sometimes it is also called as the molar absorption coefficient, right? Thus the Lambert-Beers law, it can be represented like this. Okay, so this is called as what? Your molar extension coefficient. This is called as molar extension coefficient. Amount of light transmitted, which is given by what? Transmittance. Okay, and transmittance, which is what? T. So the mathematical statement or relation between the absorbance and transmittance is given by T equal to IT upon I0, or absorbance A equal to minus log of T. So this is the mathematical relationship between what? Absorbance and transmittance. So transmittance, it is the ratio of intensity of incident light and transmitted light, right? And absorbance is the minus log of what? Transmittance. Okay, and what is the statement of combined Lambert Beers law? That is absorbance A is directly proportional to what? Path length as well as the concentration, right? So I hope that you understood this concept. So if you have any doubt regarding to Lambert's law, Beer's law, then combined Lambert Beers law or electromagnetic spectrum, you may post your doubt on Google Classroom, right? Thank you very much.